Today we'll embark on a discussion or investigation of the digestive system, chapter 23 in our Human Anatomy and Physiology text. And in this part one, we'll first look at some very general principles associated with the digestive system and its function. Here are the organs that we'll be talking about. Firstly is the alimentary canal, or the so-called gastrointestinal tract. It's just a long, hollow pipe zigzagging and twisting its way through the body. And we've mentioned this early on in our course as being an organ system external to the body. You could pass all the way through the alimentary canal and never cross any boundaries, any epithelia into the body. The mucous membrane lines this tract. Then we also have some accessory organs. We have the teeth, which produce mechanical digestion. We have the salivary glands, which add some secretion into the oral cavity. We have the liver and gallbladder and pancreas, accessory organs that add some materials also into the digestive tract that allow digestion and absorption to take place. So esophagus, stomach, small intestine, large intestine, and then the accessory organs. These 6 processes make up what we call digestion. First, ingestion, we bring in raw materials. Mechanical breakdown, the mastication it's called, chewing in the oral cavity using the accessory organs of teeth. Digestion, we're going to add a bunch of chemicals starting with the salivary glands and continuing through all of the alimentary canal organs and accessory organs. Break down all the macromolecules into their monomeric subunits. Propulsion is just mixing and moving stuff around, right? We'll talk more about swallowing, glutition, deglutition, peristalsis, movement of stuff through the digestive tract by muscular action, and also mixing. So we have digestion, breaking down macromolecules into monomers, absorption of those monomers into the blood and into the lymph, and then finally defecation, getting rid of the materials that are not digested. 2 kinds of muscular activity in the alimentary canal. Peristalsis refers to waves of contraction in the pipe that propel material en masse through the system from one place to another. Whereas the typical thing that's happening is segmentation. Hours of segmentation in which alternating places in the smooth muscle wall are contracting and relaxing, producing this mixing back and forth and slowly moving the chyme, it's called, through the tract. This slide is an attempt to give you a schematic diagram of the regulation of the whole digestive tract. It turns out that the digestive tract has a lot of neurons built into its wall and a lot of sensors, a lot of receptors, sensory neurons that feed into those neurons. This plexus is called, the so-called intrinsic nerve plexus of the intestinal system, and activate those the function of the plexus, which is to turn on muscles and glands so we can get the digestive process rolling. So when we add something to the digestive tract, chemoreceptors, osmoreceptors, and mechanoreceptors recognize its presence when we eat food. Those cause what we call local reflexes or short reflexes. Short reflexes refer to this activation of the enteric plexus and then activation of glands and smooth muscles, and we have digestion. Well, it turns out that those same sensory neurons also send information along afferent pathways to the central nervous system, and the result being that we have autonomic outputs, sympathetic and parasympathetic neurons that then modify the functions in the enteric plexus and again control the muscles and glands. So built-in nervous system of the gut involves short reflexes, and long reflexes involve the autonomic nervous system. This slide shows the peritoneum, or the idea of parts of the peritoneum. We learned about the pleural membranes that line the pleural cavities and lungs. We learned about the pericardial membranes, the pericardium that lines the heart and the pericardial cavity. And there are also there's a serous membrane lining the abdominal cavity, the peritoneum. And there's a visceral peritoneum, serous membrane lining the organs of digestion. So just like the lungs and the heart, these organs can easily slip and glide on between these two membranes without any friction. So a lot of mixing and churning is going to happen in here without getting things all scuffed up. So the peritoneum is this lining of the cavity and also the lining around the organs, serous membranes. Mesenteries are places where the lining is going to emanate from the parietal peritoneum out onto the organs. This is a very complex situation because with the lungs, you can imagine just a quick wrapping of the lungs, and you have the visceral pleura. Now we have to wrap up a very complex, long, twisted arrangement of intestines, for example, as well as the liver and the spleen. So it's a little more complicated, and we have these mesenteries that kind of form these double layers of serous membrane that sort of migrate from the wall to an organ, and from an organ to another organ of the digestive tract. Interestingly, the duodenum, the first part of the small intestine and part of the pancreas, are not in the peritoneal cavity technically. They're attached to the abdominal wall, posterior to the peritoneum. Here we see the parietal peritoneum, and the duodenum here is not in there, inside of here. It's what's called retroperitoneal. Were you to get an inflammation of the peritoneal membranes, it's called peritonitis, inflammation. What could cause it? If you have an abdominal wound that allows bacteria to get into the peritoneum, then you could have an infection in there, an inflammation. If you had a breach in the intestine, or the appendix as an example, there's unimaginable amounts of bacteria in the GI tract. If there's a rupture in those, either because of a trauma or because of inflammation like in the appendix, all kinds of bacteria are going to burst out into the space between the peritoneal membranes and cause infection. Peritonitis can be life-threatening, actually. This slide gives us a general schematic diagram of the wall of the alimentary canal. This isn't really supposed to be specific to any one part, it's just giving you the general layout of things, the layers. So a few different parts of the wall grouped together are what are called the mucosa, the lining. We've talked about mucous membranes, so here we have one. We have a simple columnar epithelium lining the organ. Underneath that, a basement membrane, and then some areolar connective tissue, right? We always have areolar connective tissue under epithelia, always. And in this case, it just has its own special name, the lamina propria. Then we have a thin layer of smooth muscle called the muscularis mucosa. So all those things are part of the mucosa. Then we have a connective tissue layer called the submucosa, essentially like more areolar connective tissue with blood vessels and glands and so forth in it, and lots of neurons. And the submucosa is the submucosal nerve plexus, part of the intrinsic nerve plexus or enteric nervous system. And then we come to this thick muscular outer part of the wall, the muscularis externa. And there's typically two layers to it, a layer of circularly arranged smooth muscle cells that sort of encircle the organ, and then a layer of longitudinally arranged smooth muscle cells that kind of bunch up and allow for different types of mixing. The combination allows for a lot of mixing to take place. On the outside of this organ, if it's located in the peritoneum, is called the serosa, a serous membrane. visceral peritoneum. It's called a serosa. It just so happens that when you place the duodenum in part of the pancreas in that retroperitoneal position, then the outer surface is covered by what's called an adventitia, a layer of connective tissue that's anchored right to the abdominal wall instead of a serosa. But also within the muscularis externa is another vast plexus or network of neurons that's called the myenteric nerve plexus. So we have the submucosal nerve plexus that controls glands here, and also the muscularis mucosa, and then we have the myenteric plexus that controls the muscularis externa. It's estimated there are more neurons in the enteric nervous system than in the spinal cord, or at least equivalent. Quite impressive. So we have these two nerve plexi that control the digestive processes, activated by sensory neurons, and they turn on muscles and glands to undertake digestion, regulation of digestion. So, as we said in a schematic diagram slide just a little bit ago, the enteric plexus, plexi, are impacted by the sympathetic and parasympathetic nervous system, long reflexes that involve the central nervous system. The parasympathetic nervous system stimulates digestive processes, secretions, and motility, mixing, and so forth. Sympathetic nervous system output inhibits those processes. All right, let's look at some anatomy of the digestive system. Here we see the oral cavity. We can see the accessory organs, teeth here, and we're going to bring some food in there and masticate it, chew it. It's going to be mechanically digested thereby, and then swallowed down through the pharynx down into the esophagus. Just to remind you, we have some tonsils in here. Here is the palatine tonsil attached to the soft palate in the wall of the pharynx. We have the lingual tonsil attached to the posterior of the tongue, base of the tongue. We have learned in the past that there's a pharyngeal tonsil here in the posterior to the nasal cavity, and so those are the tonsils that help alert the immune system to what's coming in. When you swallow, the epiglottis is going to fold down over this opening to the larynx so that liquids and solids coming from the oral cavity are going to pass by and then be forced down into the esophagus, where they'll be pushed down into the stomach by peristalsis. Here's another anatomical diagram showing the oral cavity from a different point of view, and we can see again the teeth. The gums, a very unique specialized type of tissue that sort of wraps around the gums and the surface of the maxilla and mandible. And the gums are properly called gingiva. So we'll talk more about that. You can see again the palatine tonsil here in the posterior. The uvula, the soft palate, gives rise to this funny, dangling, fleshy structure here called the uvula. And you hardly ever think about it, but when you do think about it, you think, how odd is this thing hanging down in the back of your throat? The tongue, this muscular structure, it's like a complex interlacing of skeletal muscle fibers traveling every which way, so the tongue can do all kinds of mechanical movement hijinks. And the surface of the tongue is covered with various types of taste buds, papilla. There's foliate papilla, valate papilla, fungiform papilla, and filiform papilla. I wouldn't worry so much about those, just to know that there are very different types of taste buds that allow us to sense 5 different chemical tastes, quote unquote, and that combined with our sense of olfaction allows us to really do what we call tasting food. Again, we can see the epiglottis here that's going to fold down over the larynx when we swallow. Palatine and lingual tonsils in that diagram. This diagram is good to show us the location of 3 pairs of salivary glands. There's going to be the parotid glands, the sublingual glands, and the submandibular glands. So those guys have 2 different types of secretory cells that produce saliva. The the mucus cells are activated by the sympathetic nervous system. They're most prevalent in the sublingual gland. They produce a small volume of sticky mucus saliva, whereas the majority of the salivary secretory units contain serous cells in the other glands as well as in the sublingual gland, and they're mainly serous cells, and they produce the large volumes of watery saliva that you produce when you eat. Our ducts carry the saliva from these glands into the oral cavity. You can see in the green here, they've drawn in the ducts of the salivary glands. Important note, in saliva is the beginning of chemical digestion. Chemical digestion begins with the chewing, mastication. Chemical digestion begins with amylase. It starts to break down starch and down into sugars or oligosaccharides. Saliva also contains several antimicrobial compounds. We eat a lot of bacteria and fungi in our diet, and all these compounds, lysozyme is an enzyme that breaks down bacterial cell walls and helps destroy bacteria. IgA, immunoglobulins, as you know, are antibodies that defend against foreign substances. Defensins are peptides that will also be antimicrobial, and a cyanide compound. So lots of stuff in the saliva to begin to already defend ourselves against all this onslaught of bacteria coming in. And here, as I mentioned, serous cells and mucus cells are the two types of cells in the salivary glands. The teeth, you should know the pattern of arrangement of teeth. It sounds crazy because there's so many teeth, but when you actually break it down, there's two sets of teeth, the maxillary teeth and the mandibular teeth, and then in each case there's a symmetrical arrangement. So all you need to know is there are two incisors in each of four sets, one canine, two premolars, and three molars, including the wisdom teeth. And that's the arrangement of teeth that makes up, or the different types of teeth that make up your dentition. We won't worry about the so-called deciduous teeth, the baby teeth that are eventually shed throughout childhood and adolescence. Teeth are anchored into the mandible and maxilla by connective tissue fibers, collagen fibers, amounting to what's called the periodontal ligament. So they're very strongly anchored into the bone. Then there's a seal. The gingiva form a covering on the bone and seal right up against the teeth. And the teeth are covered in the exposed part of the teeth are covered with the hardest substance in the body. It's called enamel. It's not actually bone. It's a different stuff, but it's very, very hard and impervious when it's healthy. Underneath the enamel is a much softer substance, structural material called dentin. In the core of the teeth is a passageway, the root canal, in which the neurons and blood vessels are found. This is the nerve root, of course, penetrating down into the maxilla and mandible, hence the root canal. You can actually have, of course, infection of the oral cavity of various sorts. If you have a damage to the teeth by the action of bacteria, it's called dental caries, cavities. How do you get dental caries? Well, first thing that happens is bacteria start to produce a plaque. It's called a biofilm on the surface of your teeth. Streptococcus mutans bacteria adhere to the teeth and produce a sticky polysaccharide layer on the teeth. And the bacteria ferment sucrose in the diet, and the fermentation product excuse me, is an acid which then can dissolve the calcium salts of the dentin or of the enamel and begins to damage that hard protective surface. Eventually, proteolytic enzymes get down in there and really start to digest things. So we have to get that plaque off all the time in order to prevent the damage to the enamel. Brushing and flossing are the essential processes. Gingivitis is a different type of inflammation that can occur. If we don't get rid of the plaques, eventually they calcify and form what's called a hard calculus, and that forms a tremendous, it's almost like a coral reef for bacteria to accumulate in and infect, and so it will not only damage the enamel of teeth, but it will cause inflammation in the gingiva, and they'll begin to pull away from the teeth, and they'll also become very soft and easily damaged and bleed. If things continue to progress, we'll have what's called periodontitis. And we'll have an immune response to all the inflammation in there, which is going to harm the periodontal ligament. It can actually cause tooth loss. Teeth eventually, the gums recede way back and the teeth begin to be loosened and it may even fall out. This would, of course, rarely happen unless there was some exacerbating condition such as cigarette smoking or unmanaged diabetes mellitus or an infection of some kind. If you get a really pernicious infection, we may have problems, and that's what they're talking about with oral piercing. If you happen to get a bad bacterial infection, it could cause damage. So join me next time as we start talking about the anatomy of the esophagus and the stomach and how those organs work and contribute to digestion.